In this video, follow along to get some practice on the intermediate value theorem. Okay, so problem one, it asks, on what interval must this function intersect the line y equals 7? So go ahead and try this one on your own first. Okay, so before I even go into this, if you don't know what the intermediate value theorem is, I have a short that quickly explains it in 1 minute. So I will link that if I remember to when I post this video. So I would recommend you go check that out first to really understand the concept. And I hopefully explained it well in that 1 minute. Okay, so first of all, we have to note that our function g of x is continuous for all values of x. How do we know that? It's a polynomial. Polynomials are continuous for all real x. Okay, so that means our condition for the intermediate value theorem is met. It has to be continuous on some interval. It's continuous everywhere, so we're good there. So what does that mean? Well, that means at some value of x, the y value is going to be less than 7. And for some other value of x, the y value is going to be greater than 7. Okay? Because it's continuous, let's even put some numbers like 6 and 8. Okay? So at some value of x, the y value is going to be 6. At another value of x, the y value is going to be 8. So at some third value of x, because this function is continuous, there has to be some value of x for which y equals 7. The y value of this function is 7 because it's continuous. How can you jump from 6 to 8 without crossing 7? Especially because it's continuous. That's the idea. Okay, so I explained the concept of the theorem again just now. Okay, so what do? We check the endpoints of each interval. We find one in which the y value is less than 7, and the other endpoint in which the y value is greater than 7. The only one that has that is choice C. G of 0 is -1, G of 2 is 21. So some value of x between 0 and 2, the y value will be 7. Okay? There could be multiple values of x between 0 and 2, by the way, but the theorem says there has to be at least one. Okay, number 2. Given the function h of x is continuous on the interval 3 to 7, with h of 3 is equal to 1 and h of 7 is equal to 9, which of the following must be true? 1, 2, 3. Which ones are true? Which ones are false? We'll go ahead and try this one first. Okay, so let's go over the first one first. There exists a real number p such that h of p is equal to 5. P is between 1 and 9. This is true by the intermediate value theorem. Why? Well, the theorem says that because it's continuous on this interval 3 to 7, h of 3 is 1, the endpoint there. H of 7, the other endpoint is 9. So that means there must be some value of x between 3 and 7 such that h of x, or we can call it p, h of p is equal to 5. 5 is between 1 and 9, so to get from 1 to 9, you have to cross the 5. Okay? The theorem says it's within 3 to 7, this interval. This interval 3 to 7 is contained within 1 through 9, so it's true. Okay, so we can even restrict this interval a little more, actually. Okay, number 2, h of 5 is equal to 5. Do we know anything about h of 5? No, we don't. The intermediate value theorem doesn't tell us exactly where that p occurs. Okay, I believe for this one, it assumed that it's a linear line. But we don't know that. We don't know how this function h actually behaves, except at these 2 points, the values. It could increase, decrease, and increase again, so it actually could cross multiple times. Anyway, that's number 2. Number 3, h has a maximum and a minimum on the interval 3 to 7. Yes, this is true because this is the extreme value theorem. You can just think about it. If you restrict the domain to like 3 to 7, there has to be a minimum and there has to be a maximum. There's just this. It's a finite number of values per se. It's infinite, but because we restricted this interval, there has to be some value in which it's the biggest. And there's another value in which is the smallest. Okay? So that's how we think through that. That's what the extreme value theorem says, actually. Okay, number 3, I think this is the last one in this section. This is pretty quick. Given the continuous function f of x is this guy, prove that there exists a c in this interval such that f of c equals 0.24 and find c. So you need a calculator for this one. The part where you need the calculator is this find c part. Okay, but we can do the proof first. We just use the intermediate value theorem again. Okay, we know that cosine x is continuous for all real numbers. That's the easy one. How about ln of negative x? Well, this is continuous for x is less than 0. Okay, so because this log limits the domain of the entire function f, or it's more limiting. So the whole domain should be x is less than 0. So therefore, f is continuous on this interval of interest we're actually interested in. On this interval we're actually interested in, okay? Okay, so we determined continuity. That's the condition for intermediate value theorem. So now we check the endpoints. F of minus pi is this, we need a calculator. So I guess you need a calculator here as well. And f of negative pi over 2 is 0.452. 0.24 is between these two values. Therefore, by the intermediate value theorem, there exists at least one c in that interval such that f of c is 0.24. And we can use a calculator. You can use the solver, or you can just graph this function and graph the line y equals 0.24 and find the intersection. That works as well. That's what the AP exam requires you to know at minimum, but if I remember, most graphing calculators have a solve option too. So you can use that as well. Okay, that's it for this video. Hopefully you got the points of the intermediate value theorem, and hopefully this is a review if you're reviewing for the AP exam. This comes up quite often in more conceptual questions like problem 2. If you scan through past multiple choice exams, you'll see how they ask the intermediate value theorem is usually problems like this, and they'll mix in things about derivatives and stuff and like that as well. Okay, please give this video a like if it has helped you in any way, and hopefully see you in another video as well. Bye.